All right. Okay. Hey, I'm Ajit Matthews. I drive the machine learning software development within AMD, and I have Derek with me, who is a product manager for AI computing aspects. Right. So, you heard ROCm 2.0 today announced, and I want to go into a little more detail, deep dive into it. So that's my purpose, and along with Derek here. Training and inference are the most important machine learning workloads in the data center. Our focus is in data center. All of these workloads needs tremendous amount of acceleration. On one side, the network is becoming larger and complex, and the other side, the applications are still being developed, are still evolving. So it's a perfect thing for AMD because it kind of finds home into our product. So it's a great thing for us. And our vision is that we build the best computing platform for the developers, and ROCm is the way for you to realize, the developers to realize that vision, okay? What I want to do is I will go through this stack completely. This stack was shared earlier in the morning, but if you look at it, the three things that I want to call out. Number one, this is an open source stack. You can download it today. Developers can go and start developing it. In fact, the demo that you saw today morning from David was basically developed, the automotive demo was developed on this stack. So you can do it too. It's very easy to do that. We optimize the stack from top to bottom, right? So that it gets the best performance on the AMD hardware. And the software stack is clever enough to map the right workloads. Doesn't matter whether it is GPU, APU, CPU, we are able to map it to the right workloads depending upon what the application needs are. So that's what this software takes care of. So I'm going to explain through each of these foundations next slides, right? So that's what I'm going to do here. First and foremost, one of the foundation is that we support Linux kernel. Linux is one of the key operating systems in the data center. So we upstream the Linux kernel support. We have an upstream version of the Linux kernel driver for ROCm, and it is starting 4.17. And as a result of that, we support a lot of distributions, distros, Ubuntu, Red Hat, CentOS, SUSE, and you name it. And it's great for you to just take that and start doing the development. The rest of the user space is also available in GitHub, which is a repository that you can go to and download. The next piece of the foundation is basically we have a common compiler. It's called LLVM. That's something that you must have heard of. Most of the CPUs and the GPUs use it. And as a result of that open source compiler, we are able to convert it to the AMD GPU code as an IR, and then through the AMD GPU compiler. And we also support multiple languages, like we support HIP, we support OpenMP, Python, and OpenCL. As far as HIP is concerned, if you have a CUDA application and you want to port it, you can use Hipify it, and you can run the CUDA application on it. I also want to call out, HIP is officially a language in the Clang compiler. So that's a great stride that the team has made. OpenMP, our focus on HPC application, basically showcases that we are supporting OpenMP. Python, data scientists love it, right? I mean, we are, along with Anaconda, we are supporting Numba compiler, we are supporting Anaconda, so that data scientists can easily use AMD primitives using Python language. And we are OpenCL 2.0 compliant too. So that's one piece that I want to talk about. The other piece is we have graph compilers. As you know, the machine learning network has multiple layers, and there is a lot of opportunities of fusions. So these XLA and the TVM compilers does exactly that, so that you are able to run the best on the AMD hardware. The next set of keys of the foundation is basically the tools aspect, right? And what we do is this tools provides ultimate flexibility and gives access to the information needed to debug, optimize, and scale application functionality and performance across heterogeneous compute, whether it's CPU or GPU. So we have various tools like the ROC profiler and the ROC tracer for profiling and tracing. We are also working tools with the third party. It's like the Tau, the PAPI, and the Vampire. We have some university relationships, and we are working with them to get those integrated. We have a ROCm GDB. We have ROCm SMI for the system management. We also have ROCm validation suite, and this basically gives the administrators the capability to see what the status of the GPU is. And so a lot of different tools that's available today. You can download that, and again, you can go and add the new functionalities as you want, or the developers want. Right? Libraries are the important piece of the machine learning network. So we, for example, the GEM, general matrix to matrix multiplication, that's a very core functionality of the machine learning workloads that we need to make sure has the highest efficiency. So I'm proud to say that we are up to 97% hardware efficiency as far as this from a software point of view is concerned. And we have various different libraries like the basic ROC Blast, for example. We have ROC Sparse to do the sparsity matrix related operations, and we support different FP64, FP32, mixed precision, INT8, INT4 to do the best optimized machine learning workload that need to be run. The next slide basically talks about the library aspect with respect to the multi-GPU, multi-node communication aspects. It's very important that with a petaflop kind of workload that is running, you need to have the ability to run on multiple GPUs, and our software is able to basically scale it through multiple GPUs. So we have something called as RICL, which is the Radeon Collective Communication Library, and we have optimized that. We have RDMA support, so that you can do a remote direct memory access, and that we support through we support that both on the InfiniBand and ROCE, converged Ethernet high-speed network fabrics, and we also have an easy way to do the MPI integration. Okay. If you saw the demo today in the morning, it is using a lot of different model capabilities. Like it's using the convolution aspects, right? We have a Vinograd convolution which has been implemented. We have activations which supports right from ReLU to sigmoid to tanh to leaky ReLU that we support. And we have different fusion layers that's also been implemented in this library. The good thing, again, as I said, you can download this. If you want to improve upon this libraries further, you are most welcome to do that. It's again available. So that's the beauty about this, this open source libraries that's available versus being locked in. The last piece that I want to also talk about before I give to Derek is basically the amount of improvement that we have done purely from a software point of view, from a ROCm 1.7 to ROCm 1.9. We have achieved about 36% year-on-year performance increase with the same hardware. Now, if you remember the talk that we had in the morning, we went from MI25 to MI60. We had a 2.7x improvement. So once we get the ROCm 2.0, you will see a, additional bump, significant bump running on a MI60, for example. With that, I give it to Derek to talk about the applications and the next key aspects.
All right, thanks, Sujit. So on that foundation that the hardware and software teams have been building, everyone wants to run machine learning applications, TensorFlow being the most common. So today we have version 1.11. It's available. You can download it as a Docker container. But we've been spending time doing the upstreaming, and this is where it's more interesting. Just like the Linux kernel, it enables developers to go to the main repository and get the version that's mainstream. We're not chasing the next version all the time. So we work closely with Google and TensorFlow to do that. Also with Facebook in PyTorch and Cafe2 to get the upstreaming components as well. And you heard this morning about Paddle Paddle and our Baidu efforts. Originally we had our HIP Cafe port. So Cafe is probably not used as much for new development today, but there's a lot of deployments in the industry that still use it. And MXNet is really interesting for AWS and their solutions. So what's the easy way to deploy these components? So once you have that Linux kernel upstreamed, and you just download a Docker container as an application self-contained component, there's very little effort to compile all the libraries that we talked about. You don't have to go to GitHub and download it and figure out why it didn't compile, or your platform is broken, or some other issue. A Docker container makes life easy to do the application development. So as a machine learning developer, they don't want to spend time doing that. And we have Docker images available on the Docker Hub for TensorFlow, the latest ones there, as well as a lot of the other base components for ROCm. So it depends on your application. You'll find the exact version, or you can take the Docker containers and build your own. And we've had customers that do that. As part of the deployment strategy is Kubernetes. So again, we have a device plugin for the GPU. It's I would say a beta concept. Kubernetes was deployed for CPU systems originally, and GPUs and other accelerators are being added into it. So we're helping participate in the development of that as well. So another easy way to actually start a machine learning application is with a cloud service. So you can go to GPU Eater today, use an AMD hardware, ROCm stack, and run a TensorFlow job just by submitting your Visa card. Genesis Cloud is another partner that has solutions available, and if you come to SC18, you'll see some other interesting demos. So what's happening in the application space and in the networks? So originally, a lot of people spent time in the CNNs, the convolutional neural networks. Then there's a lot more research happened in the RNNs, recurrent neural networks. But most recently, the GANs have taken over in terms of some very interesting research topics. And even this morning, you could see in the demo how the system needed more data to train itself. And once you get that level, you need a lot of data, a lot of performance, and a lot of throughput. And we have that with the ROCm stack and the hardware we have. But what's also interesting is there's so much research happening in this field that next year we probably won't even recognize which networks are there, or there'll be new networks. And we think our open source hardware and software infrastructure can support those kind of research projects. So it's available today. You can go to the GitHubs, find the solutions. We're improving the system every day, and look for the MI60 and MI50 support in ROCm 2.0 this fall. Thanks. Is there any questions?
Yeah, go ahead.
Sorry for a very fundamental question. In my understanding, the CNN doesn't require the FFT or the GEM or such kind of error. Such kind of library is very widely used for the scientific computing, but the CNN pre-processing or the post-processing, sometimes the gem or the FFT or such kind of numerical library is required, but the convolutional network itself doesn't require such kind of error.
Well, if you look at the convolution aspects, maybe not, right? But when you're looking at anywhere that there's a matrix to matrix multiplication that's required, that's when you use the gem aspects, right? So fully connected network, or when you're doing a ReLU aspects, for example, right? So the activation aspects. So that's when you would do some of those gem operations. And you need to optimize those to the best, otherwise, you're not getting the best performance.
And one more. You mentioned that the MPI is supported by the ROCm, but so it's meaning that if I writing the application with 1, 2, 4, 8 GPUs, so I should handle each GPU with MPI or such kind of that?
No, it's actually seamlessly, it will be taken care of.
I see.
It will be seamless.
Okay.
Yeah.
Thank you.
I think we have time for another question.
I know that most of the AI calculations take place at the memory, local memory of the cache of the GPU. But do you think that for the inter-GPU communications, PCIe 4.0 will play an important aspect, or is that just relevant to the application?
It's still dependent on the application, so the different workloads have different problem sets where you have to either move it between GPUs or it's compute bound. So it really depends on the application, but for applications that are memory bound, so people are running models in machine learning that are larger than the amount of memory available on the GPUs. So even if you had 8 GPUs in your system, they're each 32 gigabytes, the models are larger than that. They have to find a way to move the data around. But it's really application specific.
And so there are two types, right? There's a computation bound and there's a communication bound. And if your application happens to be communication bound, that's where there will be benefit to very good GPU to GPU communication that's happening. Number two, if it's requires CPU's attention, then the PCI related communication would be very, very helpful. So as PCI Gen 4 plays an extremely important role when you're trying to do that kind of CPU data migration into the GPU, for example. So that's when it helps out very much.
Yes.
My readers are architects, engineers, product designers, automotive engineers. Is your technology being used in any commercial applications that would be relevant to them?
I would say almost all applications are experimenting with machine learning. So people that are doing rendering are looking at how to use a TensorFlow app and do some kind of denoising or computational fluid dynamics. They add machine learning in their workflow so that they don't have to do as much heavy compute. So I would say almost every industry is investigating it. Some have deployed and some are using it today.
But it's all embryonic and you can't name anyone at the moment?
No.
Yeah.
Okay. And quite often those customers can just use, since you're using TensorFlow, it's an open API, they can use just CPUs, they can use GPUs, they can use other accelerators.
Yeah. Okay. Thank you.
All right, well, thanks for your time. That was great.
Thank you.
Enjoy the rest of the day.
Thanks, guys.
So we've got about 15 minutes to the next session. We're going to finish a bit early, so feel free to either stay here for a few minutes or head up to the lobby and then we'll give you a shout.
Now, given how much you interacted with the screen,
Sorry?
I said, given how much you interacted with the screen,
Oh, yeah.
I don't know how you did it on this side before.
Oh,
In the
okay.
last session, because you did a good job. It was
Okay.
much nicer. It's much nicer when the presenter can point to things.
Okay.
So thank you for doing that.
Oh, thank you.
And the viewers appreciate it.
Okay.
Okay, thanks. See you in the next one.
Your idea of making me stand on there was
Much better, yeah. I mean,
Thank you.
I've been to events where I see the professional videographers, and when you see, because I'm just the guy with the iPhone standing there, right? But you see them at the back, and when you watch their video, they just catch the guy bobbing around. But you never see the slides for context. And I've been to events where I've said to them, I said, listen, your guy's just going to film this guy bobbing around. And I've gone to the camera guy and said, listen, make sure you get the slides as well. Also, I've been to events where I see professional camera guys running around there, and then they stop and they go over there, and they stop and they go over there. And I say to them afterwards, I said, what was your guy doing? I said, he wasn't filming your event. I said, he was making a trailer. I was filming the movie. Well, I mean, if you're going to go to all that trouble, you should film the whole thing. There's no point stopping and walking across there. You're missing whatever is being said. So anyway, thank you very much. Thank you. I don't watch The Walking Dead, but people must hassle you about it all the time, right? I know that much. What you need to do is carry a baseball bat around with you and say,
right.
yeah, you want to know about that? You really want to? I mean, get a little one like that, you know, just for fun. Just for fun. It's the last season or something, isn't it?
Yes.
So it's your last chance to. So Karen, I got to find where Karen is. I like to set up early. These, I'm streaming the whole thing live. Not this bit.
That's great.
But yeah. People are
Nice
loving it.
setup.
People are loving it. Yeah. Well, unfortunately, I mean, I've got a bar that goes between the two where you can have two cameras at the same time. But then, if you move one, you move the other too.
Right.
So, two tripods it's fiddlier, but it works. Do you know where Karen is? Which one's Karen?
Karen?
Yeah, the next room.
Oh, yes. It's right over here to the left.
Okay, sweet, thanks. Are they still in there, do you know?
Yes, they should be for another 5 minutes.
Okay.
5 minutes or so.
No worries. Okay.
Okay.
Can I just leave these here for a couple of minutes whilst I go to the bathroom?
So I was just wondering.
Thanks.
Yeah, actually, like talk about
What's his last name?
and also like VR.